Okay, part 2 of this section 4 is dealing with proportions. So in solving proportions, if you remember, or maybe you don't remember, but proportions are basically two ratios set equal to each other. So I could say 2/3 equals 6/9. That's true. So this is considered a proportion. And the way we can check proportions, we think of cross multiplying. So if you would take 2 times 9, so top of one to the bottom of the other, we get 18. If we take 3 times 6, we get 18. And that's what makes a proportion true, is when you cross multiply if it works. So if you're thinking about a basic proportion, if I would say x over 4 equals 10 over 32. And we're trying to find out what x means. So if I cross multiply, so 4 times 10 is 40, and I go the other way, x times 32 is 32x. So to get x by itself, we divide by 32. And when you solve that, you get x equals 1.25. So the ratio of 1.25 over 4 is the same as 10 over 32. So there's the basic premise of solving a proportion. So let's look at page 31. On page 31, we actually get to, they have a couple of examples of proportions dealing with maps, and we'll get to some of those in a minute. But at the bottom, you can see, we can figure out some what-if scenarios. So using firearm deaths. We know that Australia has 236 firearm deaths for 22.3 million people. Okay, so this is Australia, and these are firearm deaths over the population. Now we want to say, what if, so these are big what if questions. What if the U.S. had the same proportion as Australia? Well, we know the population of the U.S. is 309 million, right? And since both populations are in millions, we are okay with not writing all the zeros. So we want to know, how many firearm deaths would the U.S. have if they were proportional to Australia? So when you're looking at this proportion, let's cross multiply. 22.3x equals 236 times 309, which is 72,924. I divide both sides by 22.3, and I get the answer of 3,270.1. But if we did it this way, the U.S. would have 3,270 firearm deaths instead of the 32,000 and change that the U.S. actually does have. So you can see how you can say, if we were like Australia, what we would actually have. Okay, so setting up and solving proportions. At this time, I would like you to move on to page 32, and I would like you to hit pause and work through as many of those 6 questions as you can. I'm going to set up each proportion on here and give you the answer, but I want you to see how many you can do on your own first. So go ahead and hit pause and see what you can do. Okay, in number 1, we're talking about Evansville to Muncie and Lafayette to Fort Wayne, talking about actual miles and inches. Proportions are about consistency, making sure you're setting them up consistently. So in this problem, they tell me that on a map from Lafayette to Fort Wayne is 6 inches. They also tell me it's actually 160 miles between those two. Well, how many miles would it be from Evansville to Muncie if it's 8.75 miles on the map? Well, or inches on the map. So you can see it's more inches on the map, so it should be more miles. Cross multiply, and you should get an answer of 233.33 miles, and I did round that answer. Okay, so let's move. In number 2, if firearm deaths in South Africa were proportional to Australia. So we're saying, okay, we're dealing with Australia. That's why I have the 236 over 22.3, and we know that there are 50.6 million people in South Africa. Cross multiply, there would be 535.5, so you could probably round to 536 firearm deaths in South Africa if it was like Australia. If Canada was like Colombia, so I start with Colombia's information. I know there are 35 million in Canada. How many would there be? 9849.1, so probably just round to 9,849, which is a lot more than what Canada actually has. So you can kind of compare this to what they actually have in the what-if scenario. Let's go to number 4. In number 4, we're saying, what if the UK was like Mexico? So if the UK was like Mexico, they would have 7,037 firearm deaths compared to the 158 they actually have. So isn't that kind of crazy, the difference between those two? The process is all the same. Now in number 5, our process is a little bit different because we're not talking about the firearm deaths. We're saying if a house is assessed at $73,000, so this is the assessed rate, has taxes of $1,600. So assessed on the top, taxes on the bottom. How much tax would they pay? Well, taxes are on the bottom. If the house was assessed at $87,500, cross multiply, and we would come up with $19.17.81. Since we're talking about money, make sure you round it to decimal places because that's how money works. And in number 6, a little bit different. Okay, so conservation officers catch and tag 200 fish. So we're thinking about tagged fish to total. All right, so they tagged 200 out of how many? I don't know either. So that would be an X. Later, they catch 82, so they caught 82 total, and 8 of them were tagged. So cross multiply there, and we would estimate that there started with 2,050 fish tagged in that area. All right, let's move on to page 33 and talk about population density. All right, so on page 33, you see this table. We've got 6 countries with their area in square miles and the population. To find the population density, we're trying to figure out how many people live in 1 square area of land. In our case, we're talking about square miles. So it's people per square area. So area has to be on the bottom. So we are going to take population divided by the area to get our population density. So we're going to do the U.S. together, and then I'm going to let you guys kind of cut loose on the rest of the table. So the U.S. has 309 million people. So 309 million, 1, 2, 3, 4, 5, 6, don't forget the 6 zeros, over the area of 3,717,811. When you divide those, you get 83.11. So that means in the U.S. there are 83.11 people per square mile. Okay, so using that concept, hit pause, fill out the rest of the chart, and then come back for this page here. Okay, so you're taking the population divided by the area. Those should be your population densities. Now, in number 1, I'm going to go ahead and do that on this page. Using the data in the table above, if the proportion of people to square miles were the same in Japan as in the U.S., so this is another what-if situation, how many people would be expected to live in Japan? So we're talking about, okay, so the U.S. is our reference point. So the U.S. is 309 million over the 3717811. Compared to how many people would we expect in Japan? So I would put an X where the people are, and I put the area in the bottom. If you cross multiply and divide, you end up with 12.12, and that's in millions. Okay, so we would expect 12 million people to live in Japan. How many people actually do live in Japan? 128 million. So when you look at number 2 of how does this compare to the real, significantly less, right? Japan is way more highly dense in terms of population than the U.S. They have a lot smaller area, but they have a lot of people. So in this what-if situation, what does it mean? Well, and look at the population density. In a square mile in Japan, 877 people live there, compared to 83 in the U.S. So the population density is just very, very, very different. Answer the rest of these questions. Go ahead and answer 3, 4, and 5 here on page 33. Who has the largest number of people per square mile? Japan. Number 4, the smallest, Iceland, right? Too cold. Nobody wants to live there. And for 2 countries to be proportional in terms of their population and area of land, it means they have to have the same population density. It's not going to be likely that we find a country with the exact same number of people or with the exact same square area of land. But if they have the same population density, then it works. Okay, real quickly on page 34, we talk about the GDP, the gross domestic product. The GDP is how much a country produces, and that's in terms of services and goods. So the GDP for a country, how much they actually produce in a year. So when we talk about GDP per capita, right? Remember, not capital, capita. So when we talk about per capita, we're talking about GDP per person. So if we take the total GDP and divide it by the population, that'll tell us how much each person produces. So at the bottom of page 34, you'll see that in 2012, the U.S. had a GDP per capita of 51,720. What does this mean? Okay. So in the U.S., what does it mean? It means each person, every person produces $51,720 worth of goods or services in the given year. That's everybody. That's Bill Gates. That's the homeless guy on the street. That's the 13-month-old baby living in your house. Every person in the U.S. produces that much, right? That's the average gross domestic product. So that's kind of an interesting concept. On page 35, and I know you're excited about it, but page 35 is the last page in this section. We're going to play with a little gross domestic product. Okay, so remember gross domestic product per capita takes your total GDP and divides it by the population. So let's play with Australia here. So Australia, notice in billions. What does billions mean? Billions means 9, and millions means 10. So let's come back to that. We have billions, and we're dividing it by the population, which is 22.0 millions, and millions is 6. Now, I know that these are not technically scientific notation, but work with me here. So if I take the billions and divide it by the millions, my initial answer is 69.636 times 10 to the third. We're talking in terms of money. We don't want scientific notation anyway. So if I am 10 to the third, that means 3 decimal places. It's positive, so it's getting bigger. So I'm going to go 3 places to the right. So for Australia, 69,636 would be the gross domestic product per capita. So every person in Australia produces dang near $70,000 worth of goods and services. So when I come back here, I can type in 69636. So taking our GDP divided by the population gives us our gross domestic product per capita. Hit pause, finish out this table, and actually go ahead and answer the rest of the questions on this page dealing with the table. And I'll go ahead and do that on pages after this. Okay, finishing out this page, you'll see the gross domestic product per capita. In the first 2 questions, make sure you're paying attention. They just ask for the country of the highest and lowest GDP, not per capita, just GDP. So in number 1, we've got the U.S., and in number 2, we've got Madagascar. So going to the last of the question, answering the last questions, highest GDP per capita is Australia, number 3. Number 4, Madagascar's got the lowest GDP per capita. Number 5. China's GDP is more than 4 times the size of Canada's. Why is China's gross domestic product per capita so much less? Look at the population, right? The population of China is absolutely huge. So it makes sense that that's going to be a bigger factor. Number 6, if China was like Australia. So again, this first part is Australia because we're comparing. Here's the population of China. We want to figure out what would their GDP be, and we would end up with 94,009, and that's actually in billions because that's the GDP. How is this actual? Oh my gosh, the actual is way less than that, right? It's over almost 85,000 billions. Less than that. So it's a big, big difference. Number 7, if the Madagascar GDP were proportional to the U.S. So again, okay, so here we start with the U.S. Here's the population of Madagascar. And it would be $1,132.9 billion compared to the 9.98 that it is now. So very, very big difference now, again, with the what if using proportions. So that ends the second part of Lesson 4.